We are moving on to percent of change in our study of ratios and proportions. Percent change is simply the percent by which something is increased or decreased. You have worked with things where the original amount has been increased and then you found the final amount, or it's been decreased and you found the final amount. The difference now is we're just looking for the percent by which that item was changed. So what was changed? Well, this is where it's going to be really important to recognize the amount that is your original. It might be an original cost, an original population number, an original height, whatever it is. That original is your 100%. So we'll be identifying that in every problem that we work. We're going to learn from some examples. Question 1. An electronics store buys video games at an original cost of $25 each and sells them for $50 each. What's the percent increase? They want us to do this one by modeling it on a double number line. These number lines do not need to be fancy today. Remember, the way I set them up is I do my percents on the bottom and my money on the top, or, whatever it's measured by here. So 0% would be $0. They're selling them for $25. It says the original cost is $25, so the 25 is what's getting the 100%. $25 is equal to 100% of the cost. Well, then they sell them for $50. That's going to put me over here somewhere. So right away I can tell this is a percent increase. They even ask me what's the percent increase, but I know it's an increase because 50 is larger than 25. So when you are trying to calculate the percent increase, you're not actually trying to find what the final percent would be. You're wanting to know how they got there, what percent they would be adding to get to this point. Well, that's going to be done by looking at the distance or the difference between your original amount and the increased amount. So what is the difference between 25 and 50? To do that, I could just subtract. 50 minus 25 is a difference of $25. If I then want to know what percent that would be, I could just look at my number line to find what percent corresponds to $25. And I actually see that right here. 25 is 100%. Therefore, if I'm increasing by $25, I'm increasing by 100%. So what was the percent increase here? Well, they increased it by 100%. There are some steps that I just did. I actually typed them here so that we could review them. The first thing I really did after I got my number line situated was I found whatever the increase amount was. In other words, I found the distance between these two numbers or the difference between them. Well, what is that difference related to? It is the difference from the original to the new cost, the increased price in this case. Once I found the amount it was increased, I then determined what percent of the original amount this increase was. So in this question, I would have been asking myself, 25 is what percent of 25? It makes sense to say that 25 is 100% of 25 because they're equal. So this is a logical answer to me. That makes sense. For question 2, let's just use these steps. A store buys sweatshirts at an original cost of $16 each and sells them for $24 each. What is the percent change? So what's my original amount here? Well, the $16 is my original amount. They increased the price, so this is actually a percent of increase, to $24. First, I'm going to find the difference between those so I know how much they increased it by. To do this, I'm doing 24 take away 16. 24 take away 16 would be 8. Now, the next part of the directions there, or the steps that we used, was to say what percent of the original price is this increase. So I could set this up a few different ways, but I'm thinking back to those percent equations. And I'm going to ask myself, what percent of 16 is 8? The reason I'm using the 16 is because that's the original amount. It's what got the increase. So I need to know what percent of 16 this difference was. I could convert that into words by saying percent of 16. And I said what percent as a variable because I don't know is 8. You might need to solve this out using your algebra skills, but some of you may already know 8 is half of 16, and 1/2 as a percent is 50. So in this case, the sweatshirt was increased by 50%. Question 3. Sweaters that have an original price of $28 are on sale for $21. What's the percent decrease? Model this situation with a double number line. So I'm setting that up. I've got my zeros here. I already see, not just because they told me it was a decrease, but they went from 28 to 21. 28 is my original amount. And I know it's not going to go higher than that because we went down to 21. So I'm actually going to take that all the way to the end of my number line. They're on sale for 21. The goal here, again, is not to calculate what this percent is. I don't want to know what percent I am paying of the total. I want to know what percent they took away to get here. So I need to know this distance as well, $28 to $21. To find that distance or difference, I would subtract. 28 minus 21 is 7. So the question now would be, what percent of 28 is 7? And I can already see a way to divide up this number line. I'm seeing a lot of multiples of 7. So I'm actually just going to count by 7s here. So here would be $7, 14, 21, and then 28. This distance, that amount, 7, what percent then would that be equal to? How many total sections do I have? I have 1, 2, 3, 4 sections. I know 100% divided into 4 sections means that there's 25% per section. Because I am decreasing it by 7, and 7 equals 25% of the cost, I can say the percent decrease in this situation is 25%. So what steps did I just take? Very similar to the first two problems. This time, though, I found the amount of the decrease, but it's still the difference or the distance. I still subtracted to do that. And then I calculated what percent of the original amount this decrease was. So let's use those steps to solve this last problem. Mrs. LaFave estimated that her class average on the quiz would be an 87.6. The actual average was an 81.4. What is her percent error? This one does not come right out and tell you what the original amount is. But we know that I made an estimate what the scores would be. That's going to be before you took the quiz. And so this would have to be my original amount because it happened before I got the new amount. Is this being increased or decreased? Well, my estimate was 87.6. The actual was 81.4. So this is going to be a percent decrease. It does say percent error. That just means how far off I was, but an error could be a decrease or an increase. So 87.6 take away 81.4 is going to give me the difference between my original value and the actual value, the new value. So if I subtract this, I'm going to get 6 and 2/10. Now I need to know what percent of the original that decrease is. So I'm thinking 6.2 is what percent of the original number. Again, that's my first estimate. So it's 87.6. Let's convert that to a percent equation. 6.2 is, well, that's equals. What percent? I don't know. So I use a variable of means multiply, 87.6. Now I'm ready to solve. Don't forget, this week and last week, we've worked on solving these like one-step equations like this. When they are multiplying on one side by a number, you all are starting to catch on that then to get just one p, a p by itself, or to isolate p, I would then divide by whatever they're multiplying by. So here we're going to divide by 87.6 on both sides. That's what maintains equality. And let's see what answer we get there. So 6.2 divided by 87.6 gives me, and I'm going to round this, it's about 0.07. There is one last key to this. Because this was in a percent equation, I hope that you remember in my percent equations, the percent is in its decimal form. So I need to convert this to the percent form. And we would do that by multiplying it by 100. So my final answer here is that this would be a 7%. And because I went down from the original to the new, it would be a 7% decrease.